Hello students, this is Indrani ma'am from SID Rasayan. In previous lecture, we did some methods for the preparation of alkane. In this lecture also, I will explain some more methods for the preparation of alkanes, which are very important for class 11 and 12. So in previous lecture, I have explained 7 methods. So 8th method is from carboxylic acid by decarboxylation. Mechanism I am not explaining, only important points we will do here. Now, if you take sodium or potassium salt of saturated monocarboxylic acid and if you do dry distillation with soda lime means mixture of sodium hydroxide and calcium oxide, you will get alkane by decarboxylation reaction. So what is decarboxylation? Now see, carboxylic acid means compound is having COOH, that functional group. So removal of carbon dioxide from carboxylic acid is called decarboxylation reaction. So that is taking place here. Means you have to take RCOO Na or RCOOK, sodium or potassium salt. You have to treat it with soda lime, means NaOH, calcium oxide. You have to heat it. So what will happen? Removal of carbon dioxide takes place and you will get RH plus sodium carbonate. First, what you have to do, from carboxylic acid, you have to prepare this sodium or potassium salt. So finally, what is happening? Removal of this carbon dioxide is taking place. We are getting RH. And that carbon dioxide reacts with this to form sodium carbonate. So ultimately, what is happening from here? Removal of carbon dioxide is taking place. We are getting RH and we are getting sodium carbonate. So what is the role of calcium oxide here? Calcium oxide stabilizes sodium hydroxide and prevent it from absorbing moisture. NaOH is highly hygroscopic. It readily absorbs water from the atmosphere, which can affect this reaction, means which can affect its reactivity. So we need calcium oxide along with sodium hydroxide. Now see, if you are having sodium formate, sodium salt of formic acid, if you treat it with soda lime, so what will happen? Just think about carboxylic acid, this formic acid. So what you have to do? You have to eliminate this carbon dioxide. So you will get hydrogen plus from here you will get sodium carbonate. Similarly, if you are having CH3COONA, sodium acetate, if you treat similarly with soda lime, how to decide the product? Think about acetic acid. Remove this carbon dioxide. So what you will get? Methane plus sodium carbonate. How you are getting sodium carbonate? For that you should know the mechanism. That one I am not explaining here. Similarly, if you are having CH3CH2 COONA, by similar treatment, you will get ethane. So if you take sodium salt of this and this acid and if you treat it with soda lime, what are the products? So from here you think COOH and remove carbon dioxide. So what you will get? By decarboxylation you will get this. And here also you think about COOH, removal of carbon dioxide will give the same compound. So here starting acids are different, or sodium salt of acids are different, but here you are getting isobutane. So to get isobutane, this acid or this acid you can take. Next method is from carboxylic acid by Kolb's electrolysis. An aqueous solution of sodium or potassium salt of carboxylic acid. Carboxylic acid means RCOOH. Its sodium or potassium salt on electrolysis gives alkane as the major product. Now see, this is sodium salt of carboxylic acid. Two molecules are involved in the reaction. So by electrolysis we will get alkane and carbon dioxide at anode, and at cathode we will get sodium hydroxide and hydrogen. So we can see that the concentration of sodium hydroxide in solution is increased with time. So pH of the solution is also increased. By this method we will get that alkene which are having even number of carbon atom. Means we will get symmetrical alkane. We will get alkanes with even number of carbon atoms. Now for example, so if we are having sodium salt of C2H5COOH means propanoic acid, means sodium propanoate, what we will get? We will get this alkane. Just double this part. We will get this alkane plus carbon dioxide plus NaOH and hydrogen gas. By this method we will get also ethane plus ethene plus C2H5 COOC2H5 ethyl propanoate. This is ester. These products in minor amount. So these are minor product and this one is major product. So what we have to do, from this part we will get this alkane, this alkene and C2H5COOC2H5, this ester we will get as minor product. Sodium salt of butanoic acid by Kolb's electrolysis method will give, just take this part and double it because two molecules are involved. So here we will get CH3, CH2, 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 CH3. This alkane plus carbon dioxide plus hydrogen and NaOH. This is in major amount. And minor product, from here how we can write? From this part, just form the alkane CH3, CH2, CH3, propane plus propene, make from this part make alkene, propene plus CH3, CH2, CH2, COO, CH2, CH2, CH3, this ester. So these three products are in minor amount. We have seen by this method we will get that alkene as major product which is having even number of carbon atoms. So this is having even number of carbon atoms. Now if we are having a mixture of carboxylic acid salt, what products we will get? All possible alkanes we will get. Means from here we will get combination of this and this, we will get this alkane. Combination of these two will give this, and combination of these two will give plus carbon dioxide, hydrogen, and so here we are getting mixture of alkane. Those alkanes are having boiling point very close to each other, so it's very difficult to separate these alkene by fractional distillation. So this method is only good method for the formation of alkane having even number of carbon atoms, means symmetrical alkane. Next method is from alkyl lithiums. Suppose RLi is alkyl lithium. If you treat it with water, what will happen? You will get alkane, RH, and lithium hydroxide. Carbon lithium bond is having 60% polar character. So here we can write this is electropositive, so delta plus, and this is electronegative, then this, so this is delta minus. And from here we know H plus and OH minus we can write. So these minus and plus will make alkane, and these two will make lithium hydroxide. Alkyl lithiums are basic in nature. So these will react with acids to form this alkane. Next method, reduction by red phosphorus and hydroiodic acid. If you are having alcohol, by this treatment, what you will get? In this place, you will get H, means you will get alkane plus water plus iodine. Now if you balance here 2, you will get 2. Now if you are having aldehyde, so this CO will be converted into CH2, so overall you are getting RCH3, alkane plus water plus iodine. Now by balancing you will get this. Similarly, if you are having ketone, then this CO will be converted into CH2, you will get RCH2R, means alkane you are getting plus water plus iodine. Here 2, that's why here 4. Now see, everywhere we are getting iodine. So we can say iodine is formed in this reaction. Now suppose we are having RCH3, it will react with iodine to form RCH2I, iodoalkane plus HI. But by this reaction our target is to form alkane, but here we are getting alkyl halide. That's why we are adding phosphorus in the reaction, because phosphorus will react with this iodine to form Pi3, so that it will be consumed, so this reaction will not take place. In this lecture till this, if you like, please subscribe. Thank you for watching.